Sorry? Yeah, so these are two separate problems. The u value here is 3x, the u value here is 4x. Yeah, yes, split it up, yeah, two independent problems. Yeah, just when you take the antiderivative, you just once you find your antiderivative, bring back your x, and then just then you do I'm here everything. Oh, yeah, so you plug it in for x, and so you go for x after you do the antiderivative. Yeah, after you do the full calculation like that. No division. All right, let's do let's do a few practice before you guys take your quiz. All right, let's review the scratch sheet. I have some up here that I can grab. Okay, let's review the yeah, so a couple of rules here. It's one less beautiful. All right, so let's review these new rules that we definitely have to know for the quiz. 1 over u du is it's the value of u. Okay, let's see to the u's rule. To the u. A to the u looks a lot like e to the u, with just 1 in front though. Times a to the u plus c. So e to the u, the original function will show up here, and the original function will show up here. All right, these are the new trig integral rules that were not part of the original 6, and they all involve natural log. Okay, so tangent, we can think of tangent as what? Sine over cosine, and what shows up? It's the cosine, right? So natural log, absolute value of cosine of u plus c, but this is a little strange because there's a negative in front. I know we don't associate tangent with negative, but cosine's derivative is sine, it's negative sine, so the negative is going to stay as part of the u substitution step. Okay, cotangent, think of cotangent as cosine over sign. So sign that's going to show up. Yeah. This one is positive, right? All right. What's secant's antiderivative? Mm-hmm. What two trig functions show up?
Secant tangent.
But what's in between those two? Plus. Yeah. Okay. Cosecant u looks a lot like this form here, but first we have a negative, and then what two trig functions? Yeah. Sorry. Hey, everybody good here? Mm-hmm.
What's e to the 0?
E to 0 is 1. Anything raised to 0 power is going to be 1. All right, why don't we do a synthetic division one here? Okay, hopefully by now, synthetic division problems are easy to spot. It's a rational function. Denominator is linear, but it's like x plus 3 or x minus 1 or x plus 5. And the numerator typically has degrees higher than 1. So we can't split up in individual fractions. We can't do U substitution. So this is a synthetic division. Okay, what do we start off with? What do we look at first?
The x minus 3.
X minus 3 equal to 0. What factor do we want to use? Yeah. Okay, we're just going to use numeric values. For each degree, we start off with the highest degree. So what number do we start off here with?
4.
4. Yeah, so we have a 4 for the degree 3. We have the -2. Good. So for the degree 2, we don't have a degree x to the first power. It's missing, but we need to have a place for it. So 0 and followed by so. Okay. Drop the first number down below the line. Next up. Multiply.
Well,
yeah. Add. Multiply. Add. Add.
97. So, is it that high the remainder?
It can be, yeah. So we start off with degree x cubed. Now we drop down to what? X squared. Every term is just going to fall by 1 degree. So x squared, x, constant, and how do we write the remainder?
97.
Over the original divisor. Okay, bring the original divisor back. So we haven't done any calculus yet, so we can't stop here, right? There's more to do. But this will be an easier problem because now we have individual problem rather than one connected messy problem. First 3 terms, we can use power rule, and the last term is U substitution. And the U value is just the denominator So power rule for the first few. And then what's the natural log rule for this here? 97. Yes, natural log absolute value of x minus 3. You can reduce that 10 over 2, make it 5 if you want.
Actually, do you substitute?
It is, yeah, use substitution. So I skipped that step here. So if you want to do that, u is equal to x minus 3. du dx is 1. 97 integral of 1 over u du. 97 natural log absolute value of u.
You don't just show that stuff.
You don't show your steps, yeah. But if you feel more comfortable going through all the steps, yeah, definitely do that. But I don't want to force a shortcut onto you if you want to go through the rhythm of u substitution. Okay, let's do one more. Everybody okay so far? Okay, too many terms for us to split up. Our next option is use substitution. Could be our u value. Yeah, the entire denominator, right? All right, 5 goes to a 0. What's the rule for e to the u? E to the u times u prime. Okay, so negative 2 e to the u times what's u prime? 4, right? 4x's derivative is 4. Okay, let's do some cleanup. Cross multiply. Make your substitutions. All right, do our x's go away? Yes. What can we push out? Negative 3 over 8. What rule do we use for this? Natural log. And then bring the x back. Now, what if for some reason it was negative 3 over 8 integral of 1 over u to the 1/2 du? Do we still use natural log here?
No.
We got to do what?
Power.
Well, first we got to do what to do
Bring it
power
to
rule?
the denominator.
Yeah, make it u to the negative 1/2, and then. Okay, so just be careful. U to the first power is natural log. U to any other power, bring it down from use power rule. Okay. Fine. You have all your book bags up in the front, and we can get started with the quiz. Yeah.